Okay, great. Can you see my screen? Okay. So let's start our today's session. We will be looking at error handling today in our course. So this session focuses on how we respond to errors, so our programs will stay correct and be maintained for a good user experience. So what's error or an exception? Error is something went wrong at runtime. It might be input-output failure, it might be invalid input, it might be network down, or any errors that happen when something went wrong while the program is at runtime. And exception is a language mechanism to represent that error and unwind that call stack. Exception types include syntax errors, runtime exceptions, or custom exceptions. So in production systems, always we face unexpected issues. It might be a network timeout, it might be invalid inputs or permission failures, and doing a good error handling prevents for small problems to become a larger one. So we will catch it when it's a smaller problem. So why error happens? Error happens when users enter in the wrong format. This could be said an invalid input. Files or database records may not exist. Internet connections might be down. APIs may return unexpected responses. Hardware fails. Logic mistake happens in code. So different errors happen in our system or what we are building. So this course will teach us how we can handle those errors gracefully. So why do we handle errors? Error handling protects both the user and the system. So it provides meaningful feedback for the users. It cleans up resources, files, DB connection, or processes. It allows graceful degradation and retries, and it avoids security leaks and consistent mistakes. Okay, so the first one is the try except method. So this one we will how we are using the error handling mechanism is we first will have this columns try and except. So the first thing we do is we will make our code that might get us an error in our try block, and we will catch it how to recover or how to make that code give us the correct information that we need, or handling that error gracefully. We will list that on our except section. So try means attempt this or do this. Then if something goes wrong, the except block takes over instead of crashing the program. So this will help us to investigate what went wrong, to know exactly what the error is. So the code inside the try is attempted first. Then if it works, the except block is skipped. But if it fails, Python will give us we will jump to the except block. So example of handling bad input, we can see here. We will put our attempt here. The first thing we are giving the age to be given by the user. So we have inputs and we replace the age. Then we will print that age. So what we are handling here is a value error. So invalid number, please enter digits only. So if someone or while we are running this program, if we enter not a number or letters, it will give us an error. But that error is handled gracefully, so it will print invalid number, please enter digits only, or anything that we need to display here. So the user interlater, if the user interlaters, the program will not crash. It will give us helpful feedback. So in this program, int exactly raises a value error if the user interlaters. Without trying except the program will crash. But here we are catching the error and responding with a helpful message instead of crashing the system. So this is a real-life error handling used in most apps, in websites, in most programs. So we have also else in finally. The first thing I explained that on the try block, we will give it the code that we need to be investigated, or if there is an error that would be cached. So in the except block is giving us the message that we need to give for the user. The else will run only when no error is happening here. So on our first, you can see my screen, right? Okay, if you have any issue, just let me know. Okay. So I first explained on the try, we have some code. Then on the except, we will catch the error if there is any. But here, we are just getting the number that on the try block. If there is no error, there is nothing that will run. Only the program will run. But on this specific code, the else will run when the try block is successful. So if there is no error happened, the else will run and it will give us a success message. And the finally always runs like for the perfect clean. It's perfect for cleanup. So else is useful to keep resources logic separate from cleanup and recovery logic, while finally is the right place for guaranteed cleanup, like closing files, releasing logs, and like that. So finally is for cleanup in runs no matter what happened, even if the return or raise the try instead. So else runs only when there's no exception happens in try. And so we will use else to keep the logic that should only run on the success scenario. So processing the file or anything that makes our code successful. Okay, so we can also raise sometimes our code might create errors to enforce rules. If we want to enforce our rules, we will have to raise our own errors. So sometimes when our code must create errors when the data is invalid, this stops the program early and prevents incorrect values from spreading. So here we are doing that, setting a rule to set the price greater than 0. So if the price is less than 0, we will raise our own error that will give a feedback for the user. So price cannot be negative. So this is our own rule. This is not the issue with the code, but we have our own rule, and we will ensure that using this using functions. Custom exceptions are that make your error message clear and specific. So we have class with some exception, and we have also a function here that will raise invalid age error, so that we can use custom exceptions to make our error message clear and specific. Here we have the return pattern. So there might be network fails frequently, so we might need to retry. Instead of giving the error message or giving a feedback, we might want to retry it. So here we are retrying 3 times. So if the program fails, it will retry again 3 times, and if it is continuing to fail, so it will give the error to the user. So this will help us to increase reliability, to reduce user frustration, and it avoids immediate failure due to temporary issues. So our here the best practices are catching specific exceptions, and so never using a plain text. Then keep try blocks small. So for each code, we have to divide it and make the try block small to know which specific error we are facing, and raise exceptions for invalid data. Always clean up resources using finally. Using finally is best practice to clean up resources, and using custom exceptions for clarity. So these rules make our code predictable, maintainable. Also, it will help us to debug it easily. So do you have any questions, or just let me show you some demo how it works? Is everything clear? Shall we move to the demo? Okay, great. Okay, here I'm having some code that I have shown before to enter a number and to check if the number is correct or not, what kind of error we will get here. So let me run this code, and it will expect me to give to provide a number. So it's asking to enter a number. Is it visible, or just let me make it some? Okay, so here it's asking to enter a number. Okay, let me just enter a number here, and when I enter, it's successfully give me the output. So now let's make an error. So now I will be giving it a letter. So when I enter it, it will show a value error. It shows invalid literal for int with base 0. So this is not specific, or this is not like it will not give us the thing that we need. We can't understand it more. So to understand it and to make our error more graceful without breaking the code, what we are going to do here is we will provide a try and accept block. So for invalid input, here I'm doing the try, I'm putting the code in the try block, then I will catch that error on the accept block. So here it will ask me to provide a number. If I insert a letter here, so this will give us that's not a valid number, or what we have listed on our accept block. So this will be handled gracefully. It will not show us this kind of error. So this is a perfect thing to do to make our programs stay correct, and also to maintain a good user experience. You can check here also for file handling. We have different error handlers. So for file handling, we will use file not found error on our accept block. So I have provided some code here. Let me just run it. And because our sample.txt is not found, it will show us a correct message here. Now let's try to check the try, accept, else, and finally together. So I'm here running a code to open my a data that's not found. So let me check what will happen. So when we run it, the try block is first running, then it has an error. So it will move to accept block. It will run the accept block, and it will print what we have given it on the accept block. Then it will skip else because else is running only on uh, successful exposure of try message. That when the try code runs successfully, it will the else run and the else will also run. But if the try is a failure, then else will not run. So it will skip the else block and it will move to finally. Then finally will be printed even if it's an error or not. So finally is here executed. So anything here not clear? Would you need any explanation on this? Or is everything clear? Okay, thank you so much. So if everything is clear, we can end our session here. But if you need any help, you can always address us on Slack. So thank you so much for attending. Bye.